So here we have x and y given in the parametric form. That means it depends on the parameter theta. Using this fact, we have to find out the second derivative of y with respect to x. So let's begin. So here we have x equals to a times cosine cube theta, or simply a times cosine of theta whole cube, means the same thing. Now we'll take the derivative with respect to theta on both sides. So here a is a constant. That means we have a multiplied to derivative with respect to theta of cosine theta raised to the power of 3, which just gives us dx over d theta equals to a times. So here we'll apply the power rule followed by the chain rule. So we have 3 times cosine of theta whole thing raised to the power of 3 minus 1 multiplied to derivative with respect to theta of cosine theta. So this gives us 3 times a, so cosine theta raised to the power of 3 minus 1, so that's cosine squared theta, times derivative with respect to theta of cosine theta, so that's negative sine theta. This gives negative 3a times sine theta times cosine squared theta. So this is the value of derivative of x with respect to theta. So let's label this as equation number 1. Now what we'll do, we'll find out y and find its derivative with respect to theta. So y is given by a times sine cubed theta. The derivative of y with respect to theta, so that will be equals to a times derivative with respect to theta of sine cubed theta, which is simply sine theta raised to the power of 3. So this gives us a times, we have 3 multiplied to sine theta raised to the power of 3 minus 1. Here we have applied the power rule followed by the chain rule, which is d theta of sine theta. That gives us 3a times sine squared theta times derivative of sine theta as cosine theta. So this is our dy over d theta. So let's label this as equation number 2. Now what we'll do, we will find out dy over dx. All we have to do is take derivative of y with respect to theta and divide it by derivative of x with respect to theta. So this is equals to, so the 2 is 3 times a times sine squared theta times cosine of theta divided by negative 3a times sine theta times cosine squared theta. Fine. So here 3 and 3 gets cancelled, a and a gets cancelled, 1 sine theta from the numerator and the denominator, and 1 cosine theta from the numerator and the denominator gets cancelled, which leaves us with negative sine theta over cosine theta. Now the ratio of sine theta over cosine theta, that's tangent of theta, so that means dy over dx equals to negative tangent theta. So let's label this as equation number 3. Now what we'll do, we'll need to find out the second derivative of y with respect to x. So that means we'll have to take the derivative with respect to x on both sides. So that will be equals to negative derivative with respect to x of tangent of theta. Right. Now, derivative of dy over dx, its derivative with respect to x gives us the second derivative. So we have second derivative of y with respect to x equals to negative. So derivative of the tangent function is the secant squared function. Now here we have theta, so we will multiply it to d theta over dx, which is obtained as a result of the chain rule. Now we have to find out the value of d theta over dx. Here we have dx over d theta. So if d theta, so we'll take equation number 1, take its reciprocal, which will give us d theta over dx. So that will be equals to negative 1 over 3a sine theta times cosine squared theta. Fine. So we have negative secant squared theta multiplied to negative 1 over 3a times sine theta times cosine squared theta. So finally we get the second derivative of y with respect to x. So this will be equals to, so with this negative and negative gets multiplied to become positive. So we have 1 over 3a cosine squared theta. When it goes to the numerator, it will become secant squared theta, and we already have a secant squared theta. So this will be secant raised to the power of 4 theta times n sine theta. When it goes to the numerator, it becomes cosec theta. So this is the value of second derivative of y with respect to x.